Hello, everyone. We'll take couple of minutes for other people to join. Thank you for being here.
All right. Good morning, everyone. Thank you so much for your time this morning for our final webinar of the PLOTO project. My name is Audry Maulana, and I'm the coordinator of PLOTO. We'll give, I guess, one more minute to let people to join, and then we can start. I hope everyone can see my presentation, my screen. Perfect. Thank you so much. Yes. It's always a good idea to spend a Friday on on a 3 hours webinar. It's a good way to start the weekend, I would say.
What could be the best way to spend Friday, dear Audrey? Yes.
Exactly. Okay. I think we can start. Yes. Good morning, everyone. As I mentioned before, my name is Audry Maulana, and I'm the coordinator of PLOTO project. And as you may know, this is the final webinar of PLOTO, and this is our baby for the last 4 years or some and a few months. So we're very excited to have you here and to present our project. What have we been doing, and then the impact that the PLOTO has given to our use case and our stakeholders as well. So before I begin with my presentation of what is PLOTO, I'm gonna show you the agenda of the day. So we're gonna have the welcome and short introduction to PLOTO, which will be presented by myself. And the next one is we're going to have a keynote speech of half an hour by Professor Vamvatsikos from NTUA. And then we're going to have the PLOTO Platform showcase. So this is a place for us to show the PLOTO. There's going to be a live demonstration of the platform and an overview of the key features, tools, and user workflows. So you can see what is PLOTO Platform and how can people benefit from the platform. And then after that, we're going to have a use case discussion. This is basically like a discussion from our use case partner from Liège, RRT, and BME that will show you the main outcomes and their experiences of using the platform and what kind of practical benefits that they think the platform can have. And how also the platform can support the decision-making and operational value. And then finally, at 12:45, we're going to have a short Q&A, of course, for 15 minutes. Probably not all the questions will be able to answer, but we will try our best. And if there's more questions, we will answer them by email after the webinar. A few housekeeping. This is the session will be recorded, so this is already recorded and will be uploaded to our social media channels. So I hope everyone is okay with that. Yeah. And if you have any question, please ask your questions in either the Q&A or in the chat section. Gino will be monitoring the questions, and then we will be able to go through your questions in the appropriate time. Yeah, and I think I'm missing a point, but yeah, have fun. This is gonna be a very nice webinar for very informative, hopefully. Yeah, without further ado, then I can already go to the introduction of the project. So PLOTO in a nutshell, the project name is very, very long. That's why we only call them as PLOTO. It's an easier way to call the project. So we started the project in September 2022, and then the project ends in 28 February 2026, almost a month ago. It has 20 partners with interdisciplinary skills and talents, and we combine all these resources for a project. The partners come from 8 European countries, including Belgium, Germany, Finland, Hungary, Slovenia, Romania, and Greece. PLOTO starts with the challenges that we have in the inland waterway sector. The first challenge that we have is the European inland waterway span over 41,000 kilometers, which is very crucial for freight and passenger transport. But there is, of course, with the coming challenges of climate change, this hinders the effectivity and then the navigability of the inland waterways. So this is the first challenge that PLOTO wants to address. In addition to that is also we see that there's going to be one second. Let me sorry. Oh, here we go. The freight transport is very, very important for the EU single market. It's a vital for EU single market, and is a well-performing and dynamic aspect of our productivity. And in addition to that, in the EU surface freight traffic is expected to rise by 53% by 2050. But this sector growth, it does not come without complications. As you may imagine, there's a lot of saturated infrastructure, carbon emission goals, and energy constraints. The next challenge that we see is the development of green ports and multimodal transport requires smart and integrated solutions. We're not only talking about the infrastructure. We know the infrastructure is a lot of them are not enough for the number that we have, but it also they have an urgent need for a concrete roadmap to sustainability. The third challenge is increasing frequency of extreme weather events coming from the climate change that threaten the reliability of inland waterway infrastructure. So these extreme events is also including such as storm or drought that will affect the navigability of the inland waterways. In addition to that, the earthquake also poses serious structural threats to our aging waterway and land link infrastructure. This is a very important point because in PLOTO, we're not only considering the inland waterway as a one aspect, but we also want to consider the linked infrastructure to the waterways, such as railways or the highways and the power supplies and things like this. So based on these challenges, we aim to address the multi-hazard risk understanding, smart prevention and preparedness, as well as faster, adapted, and efficient response. So we develop a new integrated system to support operational and strategic adaptation and mitigation measures by better absorbing and efficiently recovering from climate change impacts. The overall goal of the project is also to increase the resilience of inland waterways. We do this by a specific methodology that we use. So PLOTO is a very much user-driven project. So that's why we design our methodology composes of we design the pilot activities together with our end users partners. We adopted an agile development and startup mentality, so we're not afraid of breaking things along the way, you know. So we learn from our mistakes, and and then we produce early prototypes validated with stakeholders in intermediate schedules for continuous amelioration, and we engage an interdisciplinary team of experts. So this is the modular design that PLOTO adopted. So as I mentioned, coming from the hazards that I mentioned previously, such as drought or a flood or storm, we'll take a look at our assets, which is the inland waterways, but we also consider the link infrastructure such as the railway, the highway, and the power, and we create network from these assets. And then from this network, we connected them. We connect them with other types of networks, so we can come with interconnected networks. And this all created the inland waterway and hinterland digital twin. So yeah, I'm not gonna go into detail about the methodology of each of the PLOTO. The Professor Vamvatsikos will be able to go in more detail in his speech later. But this is basically our methodology of PLOTO. So we use a lot of computer vision and machine learning techniques, as well as middleware and data fusion and digital twin, and a common operational picture as well. So the use cases and scenarios. I've talked about our previously about our use cases, but we have 3 use cases in PLOTO. We perform extensive tests in 3 different demo sites, so each one of them has a similarity, but has also a lot of differences between them as well. For example, case study A in Danube area. This is a collection of smaller ports. So it's just not one port, but I think there are 6 ports in the area. So that includes the waterways and inland ports. In case study B in Budapest, this is a very interesting case study because it's connected to the railway. This is an inland port and it's connected to the railway. And then in case study C in region of Wallonie in Belgium, this is a very highly urbanized area in Wallonie, in Liège. So yeah, this is also another type of use case that we want to see and use as well. We're gonna hear more about the case studies in a later section of the webinar. But the demonstration focuses on the following objectives. So we improve multiple hazard assessment and strategic management for protection of the inland waterways, ports, and sections. We improve strategic and operational decision making, and we test the various PLOTO outcomes in real-scale critical parts of the inland waterways. So this is why the use case partners are very important in PLOTO, so to validate our findings and our solutions as well. Okay. These are the target groups that are our stakeholders that is we engage during the past 4 years. Of course, the regional and national water authorities is part of the very important target group in our project. Passenger organizations, freight companies, industries, but also what's interesting is also reinsurance companies, the shipping industries. Of course, obviously, relevant research and industry community dealing with hydrological and climatic modeling, remote sensing, and ground monitoring for inland waterways, which some of them are part of the consortium of PLOTO. And then, of course, we also need standardization organizations at EU and global level, so we can bring the results of PLOTO to a higher level. These are the results that PLOTO achieved. So we created a climate-aware crisis management by providing real-time information of the weather conditions. We model the risks and assess them to the inland waterways elements vulnerability. We analyze framework to enable the flow of information from hazard to system risk or resilience. We also created a system that integrated data from 3 remote sensing levels, so from satellites, unmanned aerial vehicles, and ground, with a focus on optimal use of different sensor type. We model and simulated environment for assessing the resilience of inland waterways and potential impacts due to various hazards. And then finally, we integrated the prototypes and executed of the project's pilot based on the defined scenarios. So these are the impacts. Well, we ensure navigability for inland waterways by assuring at least 50% capacity during extreme weather events. We enhance infrastructure resilience to extreme weather and human caused events by assuring at least 80% capacity at network level during the disruptions. We ensure resilience and smooth functioning of passenger mobility and freight transport or logistic networks operating on these infrastructures. Of course, these are all based on our use cases in the 3 regions I mentioned before. And we increase the use of recycled materials, and we reduce environmental impact during construction, maintenance, operation, and decommissioning of the infrastructure in line with the EU environmental legislation. So these are PLOTO project in a nutshell. Of course, we're going to know more about the PLOTO and how we have worked these past 4 years in the next sessions. But yes, that's it from my side. Thank you so much for your attention. Then we can go ahead and go to the next session, which is the keynote speech by Professor Vamvatsikos. Professor?
There are some minor technical issues, just finding the,
Okay, that always happens.
please. Of course.
There we go. Hello, everybody.
Hello, Professor. How are you?
I think I joined as a participant. I'm fine, actually. I'm in a cafe, so you might hear some background noise. But it's my semi-vacation day, so. All right, let's share a bit of a screen here.
Yes.
See, there we go. All right, hopefully that's visible to everybody.
Yes, we can see your screen. Perfect.
Super. Well, just to give you some idea, I'm gonna try to place a little bit of PLOTO into the overall vision of the European Union, at least as I get to see it. And if you will, the idea is that we want to protect critical infrastructure from weather hazards, geohazards, climate change, well, everything that's out there and nature is showing at us. And the concept is we want to use tools and services, novel technologies, to make something better out of what we have already. And in our business, in our line of business, if you will, this is risk assessment, right? Because that's the one way that you can figure out all that is coming at you and take full stock of them and prioritize. The aim, classically, for all of these projects, styles of project awareness, preparedness, response, prioritization, and everything as much as possible in an integrated system. Why integrated? Because we want a single point of information where you can gather everything, look at it, judge, and decide. I tend to like to go through the lingo and the buzzwords. And for me, the classic example I like to make is the case of persons that are genetically have the genes of no pain. Actually, they lack the genes to feel the pain. And I don't know if you ever followed, I don't know, like the TV series House, they have an episode of exactly like that. There's a person and they always have to check themselves and make sure that they're not hurt. Why? Because they don't know when something happens. They might just walk down the street, step on a stone, step on a nail, they'll never feel it. They hurt themselves and they keep going because they don't know it. And they have to visually check themselves every time for cuts, for burns, for scrapes, for bruises. In other words, they lack the nervous system sensors, or if you will, the pathways to detect the damage. Now, in many ways, this is what we have today for, well, not among others, transportation systems. We need to visually inspect everything. You want to check out the bridge, you have to go there, you have to inspect it. Something happens, you don't know what it means, you have to go and inspect it every single time. The aim here, not just of this project, but many others, I'm guessing, is to create systems, transportation systems, corridors that can actually feel the pain. A central nervous system that can detect the damage, but it's still small, heal it early, and essentially make it a cost-effective solution. And the whole discussion is, can we make this cost-effective enough? So installing the sensors and making this a part of the infrastructure system will offset the cost downtime, over time, during the lifetime of the project. And one way to do that is to select where you put them, prioritize, make sure you do a proper management of your resources, and eventually see what you can gain as the project evolves and as the transportation corridor itself works through its lifetime. So it's a long term, but it's a good shot. To give you an idea, I'll just give you examples from similar projects to give you an understanding of the concept. It's something that Audrey, our coordinator, already showed. For example, here I'm just showing for urban areas and cultural heritage buildings. You always start with the quantification of the hazard. You take stock of your assets. You select them and put them into groups. Why? Because you need to simplify. You connect them all together into networks. And as needed, you integrate and interconnect the networks. You put them together, in this case, into a city model. You introduce the indirect stuff, the additional, in this case, a business, a social and economic model, and you have the physical risk of an entire city. Or you can have an industrial plant, again, hazards, assets, different types of assets, different types, similarities, dissimilarities. You interconnect them into a system, so you go asset to system, put them all together, and you get your physical risk of an entire facility. Same for infrastructure networks. You start from hazard, from assets to network of assets to interconnection of those in a transportation system. And each time, every single time we try to do this, it's a new challenge, a new way of interconnecting, a new way of simulating what will happen. Because once you simulate it right, you understand what's happening in the system, you understand what's happening in the individual asset, and you can say something that is smart or at the best informed about what happens, what may happen, and what you can do to prevent this. Now, how we handle this in PLOTO? Again, I have to say I'm very happy that the European Union tells you nowadays to, guys, try to put these things under common frameworks, try to reuse platforms. And in many ways, we're using and reusing concepts that we're developing and try to build commonality through them. You get your assets then, and a database, you have your hazard records again in a big database. You throw them through a simulation platform, which will give you, let's admit somebody, which will give you a series of scenarios, millions of those, of different types of damage. Green is known, black is catastrophic for every single asset. Then you go to your stochastic event sense, mean a scenario generator of natural hazard events. You throw them into a tool that will put all this together, mix them nicely, and give you ideas of system impact from low to high to moderate, both at the asset level and at the entire system level. And that's the big innovation there. Now, introducing to the system, which is the so-called all scenario long-term assessment, the concept of sensors, meaning where do you feel the pain? And that in terminology that makes sense to our hazard people will be nowcasting and forecasting, meaning what is happening right now, nowcasting, what may happen in the future, forecast. Different levels of uncertainty in each, but they're all handled in the same way as I show later. Each of those can have any type of information that can come from a occurring, unfolding, or forecasted hazard. And some examples of such sensors would be response, meaning I have actual sensors on the physical structure which read its status, for example, strain gauges, accelerometers. Automatically, I can tell if and whether the structure has experienced damage and thus remove scenarios which are incompatible with it. I can also have so-called hazard sensors, meaning a seismograph or a weather station. Automatically, I can remove stochastic sets, events that don't make sense for what I'm observing. And of course, I have impact sensors. Impact sensors are essentially, could be just a camera, could be anything that tells you, guys, it doesn't matter what the system is showing. I'm actually seeing that building alive and well and not flooded, for example, even though you're predicting something else. They're the ultimate, if you will, form of sensor. It would just be a camera looking at the building. Automatically, these can prune down all your millions of scenarios database and give you a very constrained, as we say, a low uncertainty view of what is happening, or in the case of forecasting, a sensor of the future, if you will, what may happen soon. What can be inputs to those? What kind of scenarios can we be talking about? Well, climate change, alternative climate change scenarios, weather hazard stemming from said scenarios with CFD simulation, with fine spatial resolution, meteorological data, and weather sensors. You have flood hazard, both simulated and actual measurements, let's say from water gauge sensors. You have earthquake hazard from seismographs, and in this case, simulated sets. On the right, you're seeing what we call a stochastic event sets, or meaning, in this case, Romania, all sets of potential events, earthquakes, if you will, that can happen, but darker and worse. And on the left, you see a realization of exactly such event over the lower Danube, the PLOTO case study for the Romania. And you can see whatever it's darker, it's lower. Whatever it gets hot, red, that's gonna worsen, which can tell you automatically along a long area, almost 100 kilometers, what is the expected level of damage. Put this all together, intensity measures, exposure model of assets, vulnerability function, analyzing the get losses, often curves, aggregated, and maps to show you the spatial correlation for every type of hazard. And once you have this information already stored in the PLOTO system, you can now do predictions. You can now do understanding what's happening. And let's give you some ideas of, based on this framework, how PLOTO has innovated and has introduced such concepts into something that is well packaged, integrated, a single point of entry that can make sense. And here is the basic, no-nonsense point of entry. It's the so-called integrated IMS, common operational picture of the inland waterway assessment tool platform. And here you can collect all this information, you can query this database, and you're able to see, for example, from inundation losses, histograms of flood heights, historical data. You can browse all the scenarios. You can read sensor information and forecasts. Right? Here's an example of how I believe this is the lower Danube, looks. From the top, you can see the different assets you have. You can see the different sensors, and you can zoom in and click on each one of those. You can even, if you're interested, set standard operating procedures, have resources, dispatch of police, fire, brigade, and have even a list of actions that every single time that something happens, you can call them up, you can have alerts set up, you can have a list of things to do to make sure you don't miss anything. What kind of sensors we can integrate? For example, you can see here satellite information on the left from a flood event, an extreme flood event. On the right, you can see UAV data information for updating the state of our exposure dataset. In this case, This is the Budapest port. It's a single building at the center of it. You have forecasting information, specifically for the flood assessment using precipitation forecasting, machine learning predictions to facilitate the flow of here's how much it rains. Over there is how much of the water level you're expecting. You have hydraulic models that give you the potential inundation. In this case, you see this in Wallonia, the potential inundation of the adjacent urban area, given that the breach has happened. And you can even estimate and have pre-run scenarios of which assets have been flooded, by how much, and what is the expected level of damage and losses in this area. Obviously, whatever you see red, black, is practically complete flooded damage. What you see green is you can even have an estimate of losses, not just 1, 2, 3, 4, 5. We're not talking quantitative estimates here. We're talking qualitative estimates, because something I forgot to say is all this concept has been set up on the same principles that insurance and reinsurance industry uses, the so-called catastrophe risk assessment, meaning that even though we use a different basis to introduce sensors, they don't use them. We can feed our information and output hazard and loss products directly into their models, and we can help them provide estimates back, which can be used by system operators, and governments, municipalities, to assess, prepare response, and of course, if needed, mitigate appropriately insuring, going for new products. Here you're seeing the next level of this, the system and system indirect level, meaning how would the society, how would the local economy, in this case, for example, like in Wallonia, operate? How would it function after such a flooding event? You have on the left downtime diagrams per industry, per sector of economy. You see the community model, how these are connected. Whatever you see red essentially implies that one node, for example, food and beverage, heavily impacts tourism. They don't want to come if you cannot have a lunch. And on the right, you can see a snapshot of the impact of analysis, and in this case, change in the gross value added of the community, which, by the way, for the region of Liège that we are modeling in PLOTO runs into the billions. Here's a further example, in this case, of the business operational model, which directly tries to simulate the ports. Again, it's the classic 5-step procedure we've discussed, where we're talking about the last part, not just the direct physical damage, but in this case, the indirect impact assessment of the business continuity of the operators, where the plan is to check the restoration time for the damaged assets, have the business operation model flowchart of operations in terms of demands of freight and containers and the capacity of handling them, and figure out results for each disruptive event of delays, reduced throughputs, and time to restore full functionality. And as well, even after you restore functionality, what's the time you need to eliminate the delays, meaning remove your backlog? Here's an example for the Danube basin, and I'm going to show you what Adam has prepared for the inland freight port. Here's an example of one of the ports. In this case is the docks ports. There's several more of those around. It's not just a simple port in this case. And you can see the different cranes that are operational. These are cranes on rails, on the land. They're steel towers, and they handle upwards of 800 to 1,500 tons per day. You get warehouses, you get silos, you get floating cranes, which for the case of earthquake, for example, they're essentially indestructible. Then you have kind of products that you handle. You have cereals, steel scrap, bulk, and other product. Different changes over the years as COVID went through, as industry changes locally, so the product changes as well. And you have some imported, some exported, different cases. Importing goes to inland can go to waterway can go to sea or further on the Danube. And you have a certain workflow that you follow based on the operation of the operator's experience. And here is the complete flowchart, which if I really wanted to torture you, I would read through, but let's not do this today. But the general idea is the following. If you have a disruptive event, let's say a big earthquake, which is quite possible, unfortunately, given the proximity of the branch zone in Romania, which takes out your cranes, your 6 cranes. Then that's day 0. On day 35, 2 of those are back online. Maybe you fix the rails. Maybe you fix the electrical problems. Maybe you fix the wiring. You go to functionality of 33%. You jump up in terms of product, handling capability. Then you restore another 2. You go to 66%. You restore them all. And after 43 days, you're back online, 100%, no problem. Well, yes, but it's going to take you time to fix the backlog. So you got the functionality. Now it's time to go back and make sure you have unloaded everything and reloaded everything. And here's an example of results in terms of still input, still exported, and still delays, which, as you probably see, even though you're back online by day 43, it takes you 70 days total to be as business originally happened. Here's an example of how this functions in terms of functional diagram and how the flows go from each part of the port to others, and the overall impact analysis with the 72 days restoration period. Well, I need to conclude with, I think, this beautiful example before I say thank you, and saying that what you see here is just one part of what we have in the system, meaning the same information is available for all 6 ports of the Aggelos, for Budapest, the social economy model for Wallonia, and these can operate on their own, they can operate overall, and they give you a full overview, not just a bird's eye overview, but a bird's eye overview. You can zoom in and you're able to see and understand what's happening. Sometimes it's obvious. Yes, if you take out a crane, things will slow down. But a lot of it is not. You don't know how much it's going to slow down, or you didn't. You didn't know how much it would take to restore. You didn't know how much it would take to be back to business as usual. This tool, this intuition that an operator already has, we can turn into something that's quantified. Of course, it has to be compared to ground truth to make sure it's properly calibrated and we're not missing something. And then it can become a powerful tool to help future planning, to help the future of ports, to help people operate in that waterway and its infrastructure in the best possible way. So with that, I thank you. I wish to thank you very much and give it back to our friend Audrey, the coordinator.
Perfect. Thank you very much, Professor Vamvatsikos, for your keynote speech. I think it's very, very interesting and very important to see the technical, the under the hood, as you say it, how the PLOTO project really is. Okay. Then we can go to the next session of the webinar, which is the PLOTO Platform Showcase. For this, I give the floor to Aggelis.
Yes. Hi, Audrey.
Hello.
Hi, everyone. This is Aggelis. I hope that you can now see my screen.
Yes, we can see your screen.
Okay, perfect. So I'll give you a very brief introduction in the capabilities of the PLOTO platform, and which is the main component that integrates all the other components, mainly their results, in a unified way. So let me also make it full screen. Okay. So the PLOTO platform is based on the Engage, a platform developed by Satways. Here, all the information presented through the user interface is grouped according to the different elements. So you can see that we have different options for different perspectives on the top main bar. So here you can see the incident management perspective, the procedures management perspective, resources, sensors, UAV missions, meteorological data, the risk assessment perspective, the map perspective, and some other utilities perspectives. Focusing on the actual things that we covered in the PLOTO project, let me start with the data collected through the UAV flights. Here we implemented a whole functionality of mission planning. As you can see here, we have logged all the missions, all the flights that were made by the drones for the PLOTO platform. The user has full access to managing, creating, editing, and managing the missions. And whenever a mission is finalized, then the operator is able to upload all the data from each mission directly on the platform. Let me give you a brief summary of some examples of data gathered during those flights. So here we have the results, some 3D models for the Galati port, as you can see here. And also, let's go to Braila to see some similar models from the port infrastructure. Let's go see, take a quick look. Here again, and let's go to Budapest to see some sample data from that use case. Okay. Also, 2D data are available after all these flights. For example, here are some images uploaded, overlaid over the map. And from this part of the user interface, the operator has full access to all the data that were collected and uploaded on the platform, and the actual mission of the UAV, which can be shown on the map, and downloaded, exported to KML and uploaded to the any UAV that the operator needs to use. All the information gathered, all data gathered and produced by the PLOTO components are available in layers. As you can see here, we have a huge number of layers imported into the platform. So if I may enable the defects, just to give you a quick description of what, where's the mission? Okay. What data were gathered regarding the defects. We have a huge data set of defects collected, as you can see, in each port. Different types of defects were recorded, and they are all available on the same platform. Now let's move on to the risk assessment functionalities. Let me just close the defects layer. Okay. Much easier now. So here is the, let's say, the heart of impact assessment components, as their functionality is orchestrated through the PLOTO platform. Here we have different workflows prepared according to each set of tools that are collaborating in order to produce their outcome. Let me start with some quick examples regarding filtering seismic events capabilities. So here we have huge sets of seismic events that can be filtered out. So you can see that we have earthquakes, stochastic earthquakes of different magnitudes, and the operator is able to select any of them and simulate an earthquake. When simulating an earthquake, the seismic impact assessment component is running, and its results are available through this component on the user interface. So as you can see here with the green and yellow dots, the results of the seismic impact assessment component is available. So we have either no damage for green assets or slight damage for yellow assets. Depending on each scenario, we have different results. As you can see, we have left some alarms popping up regarding the wind hazard in the area. So this is briefly how the seismic impact assessment is working. Let's go to quickly check some what-if scenarios, mainly for the Wallonia use case. These are some scenarios that are already executed. So I can select various information. Let's start with the layer on the map. So here you can see the flood extent, okay, and also simultaneously you can see the damage state calculated for the assets that are into the flooded area. Here are also some extra data. Okay, it's an issue. Yes. Some more statistical data gathered by the components regarding the possible flood losses. All this information, we are talking about a ton of information available through the platform, and for its use case, you can see some more. I hope that their size is okay. So here, for example, we have the number of assets per inundation damage state for residential GRC damage class. And flood losses. The operators are able to run any new what-if scenarios by just selecting any of the breaches simulated in the platform. The barrier height can be configured, and also the mitigation measures can also be configured, whether we have no mitigation measures or the nearest dam closes at 6 hours or 11 hours. All these different options create different scenarios with different results. Let's go to quickly check also some results from the flood forecast for the Wallonia use case. Okay, I have some issues here. Okay, let me. Okay, this is okay. So. Okay, something is broken here. So let's go to the what-if scenarios in Danube area. Okay. So here are the different data produced by the latest run of what if scenario for the Danube area. As you can see, we have the flooding aggregate direct losses calculated here for each port. So let's take a quick look at Braila, and if we find Braila on the map, okay, you can also spot on the map the weather stations available and the live weather data produced. So here, as you can see, we have, it's the previous layer also activated. Okay. So let me just refresh the page to make it quick and go to that what if scenario and the select execution. Okay, let's go to Braila. And let's take a quick look on other data available. No losses here. So this is the general state for estimated for all the different assets in different places around Danube in the Romania area. And I need to find here Galati, if I remember correctly. Here are the assets covered, and we can see all the information collected for each asset. I don't know how much time I have. I hope that I have some more time. Audrey?
Yes, yes, you still have
Okay.
around 10 minutes.
Okay, perfect. Okay, great. Let's check some data regarding. Okay, let me make it full screen. So as you can see, these are the data that you already, Mr. Vamvatsikos presented earlier in an animated format in order to make the users more familiar with what exactly is expected to happen in the infrastructure. Okay, many different information. This. Okay. And let me just show how the respective what if scenario for the Danube area is handled, as we have a different workflow here from what we did for Wallonia. So here the operator just selects the water depth estimated, okay, and the flood duration in days. So selecting all these different options, we can simulate a new what if scenario. Here you can see a list of the latest scenarios executed per category. And in this view, you can see all the components collaborating for each workflow in order to produce their final outcome. Now, when we have an actual incident in the infrastructure, the incident management is used by the operators. Through this, the operators can create new incidents by this view, filling in all the information regarding the primary type, the secondary type of the incident that is taking place. And while managing the whole incident, we have chat capabilities for all the users of the platform in order to exchange information. Of course, we are talking about common operational picture as all the users, according to the department that they belong to and the organization, they can share the information gathered for that incident. In case we are able to mobilize any resources, we have an example of two cars involved in the incident in order to mitigate the current status. And also, depending on the actual type of incident that we are handling, the system automatically proposes a set of tasks, a whole procedure, let me say, in order to mitigate the whole activity. These plans, these mitigation plans are fully configurable by the users as through the procedures perspective, the users have the ability to either edit, create or update tasks, combine those tasks in procedures by listing and combining different set of tasks. And of course, we have the proposals where each user is able to configure how that procedures will be automated. So by creating such proposals, we can assign, let's say, procedures to specific incident types. This way, whenever a specific incident type is created, a different set of, a different plan is activated. So as you can see, we have different set of tasks. Some incidents don't even have task, automatic procedures on them. Of course, part of the common operational picture are the meteorological data that are available all the time for the operators. The incidents, when managed, have a specific classification regarding their status. So at each point of time, all the platform users know what is the exact situation in the infrastructure, how many incidents we have, their status, and it helps all the users in order to mitigate the current situation. We check the missions, we check the map. Let me briefly give you some information regarding the length of the data collected and how many different layers we have on the platform. So here, as you can see, we have some layers from other components. They are also grouped in some cases like the CVDD component. And as you can see, all the information that have been used in order to run algorithms behind the scenes are also available here. So let's take a quick look on some sample data from the floods on Thessaly that were used for testing purposes. All this information are embedded into the system. As you can see now, these are the latest for Wallonia. I think that there is also an example of an actual flood in Brazil, where the data were used for testing purposes. Yes, here it is. And of course, we have implemented a subset of typical GIS functionality in order to manage those layers and give the operators the capabilities to overlay layers one over the other. Of course, resources management, all the resources available in the platform are documented and managed through the platform. So these are, let me say, the most basic functionalities offered through the PLOTO platform for managing any incident or any alarm from the sensors, and also capabilities regarding impact assessment on the infrastructure according to the hazard that we are facing. Thank you for your time. I don't know if there are any questions, or should we go later to questions?
Yes.
Audrey, back to you.
Yeah. Thank you so much, Aggelis.
You're welcome.
Right on time.
Thank you very much.
Yeah, we're gonna gather questions towards the end of the session where we can answer them. I was expecting a Godzilla event, but I didn't see them. Maybe it's for another project.
Audrey,
Yes.
this been Godzilla events were for the land-based events. This is released a
exactly.
Kraken, if you get that reference.
Kraken event.
Yeah.
Maybe it's
Sorry
not
for-
deep enough.
Yeah, sorry for our participants here. There was a time when Aggelos had given us ample permission to play with the platform, and there was a certain Godzilla event that would happen just to test the limits of the system. He did mention any alert, right? Anyways.
Thank you so much, Aggelos. Then we will go to the next session, which is the use case discussion. For this, I will give the floor to my friend Nikolaos as a moderator of the session. Nikos? Yes.
Yes, thank you, Audrey, and good afternoon to all the participants. Audrey mentioned in his introduction that PLOTO performed extensive tests in 3 different demo sites, showcasing how advanced analytics and predictive tools really support inland waterway operators when managing climate-related changes. So the 3 different use cases that they are going to be presented today will be on strengthening resilience on the lower Danube area, including the waterways and inland ports. This is our first use case. Second use case on advanced monitoring and risk simulation in Budapest port, which is inland connected to the railway. And the third use case is modeling dike breach risk in the Wallonie region. So our colleagues that they spearheaded the respective efforts, Natalia Budescu Salceanu from Romanian River Transport Cluster, Csiszár Csaba from the Budapest University of Technology and Economics, and Benjamin Dewals from the University of Liège will give the respective presentations and will discuss in particular on main outcomes, user experience and practical benefits, decision-making and operational value, and challenges encountered and lessons learned during these deployments. So I would like to invite, without further ado, Natalia to give the first presentation. Thank you.
Hello everyone, but I think I need the permission to share my screen by any chance.
Zino will step in here.
Yeah.
You should have it already as a presenter. So try to
Yeah,
share.
I think it's like Dimitrios. I have the Kraken or something now.
You are already presenter. Try to share, please.
Yeah. So let's try again to see if it's working. But it's not something. Mhm. Okay.
What's working with you? Okay, perhaps I can share your presentation if it's not working.
Or we can go to the, yeah. I don't know why.
That's what's
Yes, yes, Dimitrios, you have the power from Genome. Yeah, for sure.
Sorry. Can you
No, it's okay, but I think I will have to say like next slide, please, like several times.
yeah, that, can you send to me again the presentation, please, so I can share it?
Okay, can we go to the use case from Budapest and then we can do the
meanwhile, yes,
technical if
exactly,
something? Yeah,
Well,
Nikolaos, it's okay with you to do like this?
Yes, it's
Yeah.
perfect. I was thinking about that. So
Perfect.
Csiszár is ready to deliver the presentation. Csiszár, please, the floor is yours.
Thank you very much. First of all, I would like to say some words about the organization. It was a pleasure for us to participate in this project. And on behalf of the Hungarian team, I would like to say thank you for this opportunity. So let's begin the presentation. Do you hear me and see the presentation?
Yes.
Thank you very much. So
Yes.
from the Hungarian side, 4 companies were involved: the Freeport of Budapest, BSL, RSOE, who were responsible for the information provision and the technical background, the railway infrastructure operator MÁV, and our university, Budapest University of Technology and Economics. And as you see, many very sympathetic ladies and guides were involved in the project. Some words about the location of the Freeport of Budapest. It is quite close to the city center, some kilometers, and accordingly, it has a significant relevance, not only for the capital city, but for the central region, where approximately 3.5 million inhabitants live. It's a multimodal port, which means that railway, road, and waterway transportations are available. And recently, it is already surrounded by the city. So we may say that it's a kind of a barrier to find the appropriate railway and road connections to the port. The port is a huge establishment, and as I mentioned, it's a free port. It means that many companies are working together, and there are many cargo types. For example, fertilizer, scraps, grain, and here many containers are also managed, and there is a dedicated basin for the oil transportation as well. The challenge was here that the processes are quite complex, and there are many uncertainties, and that's why the coordination is a challenge and the prediction has a significance. And as I mentioned, the disruptions may cause significant economic and social issues, so that's why the reliability of the logistic chains are important, and not only the reliability, but the opportunity to replace the missing. So it was the introductions. So what has been done here? Very briefly, some sensors were installed on the appropriate locations to provide continuous data, and we use the existing sensors as well for nowcast and forecast purposes. Besides, data collections were done by MÁV colleagues. Many different kind of data collection technologies were applied in the first period in order to describe the assets and in order to collect as many attributes which are relevant for the predictions. Here you see the list of different type of data. Hydrometeorological data were provided by the RSOE, orthophotos, point clouds, elevation models, and so on to feed into the PLOTO system. And let's focus on the main outcomes. First of all, we begin with the user requirements, and many companies were contacted here in Hungary and in Romania and in Wallonia as well. Then the multimodal logistic chains were described. It was a kind of challenge because, as I mentioned, many type of cargoes, many different kind of activities, storage activities, loading, unloading, and there are, of course, capacity constraints. So that's why the delays should be revealed in order to mitigate the delays. The hazards. Here, the earthquake was not relevant, but the strong wind, the severe storms, floods, and ice situations were the most important hazards. And we created vulnerability and recoverability indices in order to describe the issues. Users. For dispatchers, who are the main users of the PLOTO systems, but beside them, the companies has also opportunity to use the system, and the transport service providers, the shipping companies, the railway companies, and so on. What are the benefits of the PLOTO system? The forecast of weather hazards, and according to the forecast, the processes can be managed, reorganized, or replaced. And accordingly, we can save resources, time, cost, and human resources can be saved. Impact modeling is another benefit, and the general objective of the system is to enhance the reliability and predictability of the port operations. And if something happens and the services are not available anymore, the rerouting or the detours should be managed. And another benefit, that PLOTO system provides a common communication interface for all the stakeholders, so they can communicate in a more sufficient way using the system. What is the decision making here? Tactical level, strategical level, and operational levels are supported. And the disaster scenarios have the operation, and the early warnings about the risks can help the planning and the operation. And of course, the simulation is also a relevant support for decision making. What can the operators do if they receive a warning and they see that the hazard comes or the situation is getting worse and worse? Here you see a list about the or potential activities. So they can, for example, suspend crane movements, or they can close the roofs, doors, windows in order to mitigate or to eliminate the damages. Additional activities can be done in order to protect the basins, the ships, and an important issue to inform the related companies who are involved in the entire logistic chains. So these are the actions, and the challenges were that many companies were provided data, and data were coming from different sources in different formats and with different information content, because they're using fragmented information systems, and the structure and the content were different. And our task was to understand the processes, to describe the processes, to collect or to estimate appropriate the data sets which can be inputted into the system. So the quantitative and qualitative description was a task, and in this sense, the BSL colleagues helped a lot, because they have experiences in the everyday operation. Some lessons learned. The water level is a critical issue because the drought periods is longer and longer year by years. And in this case, the port and the operator should find an alternative routes and to estimate the delays and to inform the partners. So this is a kind of lessons learned. And some words about the platform. A platform has a modular architecture, so it can be used in other geographical contexts as well. Many data sources can be used, and Budapest use case provided or tried to provide these data sets, either publicly available data sets or direct operational and statistical data were provided. A data collection was performed, and some words about the data reliability. It was also a question. There is a standard data validation and consistency check, and predefined estimation methods were used, and historical data sets. Some words about the use case, the gap. The complexity is an issue because in everyday operation, the dispatchers do not need all the functions. So it's a kind of obstacle for them. Because at the first period, they were a bit reluctanting, and later on, after some training, they saw already that it is a useful tool, but still a bit complicated for them, and not all the functions are needed. User ergonomics is another issue, is to be improved. And another issue was that heterogeneity of infrastructure and operational processes. Core principles are working well. Data integration, risk and vulnerability assessment, operational monitoring, and decision support. So in general, there were positive responses after the initial period. It is a logical, well-structured system, and the services can be used in order to forecast the infrastructure status and to assess the consequences, the impacts. This was an overview about the use case, and finally, I would like to show you a video about the use case. 3 minutes, and then we can give the floor to the other use case. Dear colleagues, as I would like to say apologize because I received feedback that you didn't hear. Is it right?
Indeed, there was no sound, but the video was still quite impressive, dear Csiszár.
Okay.
So
the YouTube link is available, so if you have time, you may listen to the voice. Unfortunately, today it was not working. Sorry. Thank you for the opportunity.
thank you, Csiszár, for this very good presentation. I would like now to invite Natalia to have another go at the presentation, if everything is okay now.
I tried it, it doesn't work. I tried it with Gino, so we're going to do a match made in heaven and we'll work together and he will share the presentation.
Perfect.
We took this into consideration. So Gino, I will say like a lot of next slide with your permission, but hope that you will. Okay, this is the link for the YouTube. Maybe we can go, yeah.
Yeah, just one sec. I'm getting the presentation. Okay.
Yeah, perfect.
Everybody see?
So yeah, so I feel like you already know about Galați more because we are like presented by Professor Vamvatsikos also, and also during the trial version of the PLOTO platform. And you can see here that we are a big team putting together 3 structure, focusing on the use case of Galați. And it's true, yeah, we choose 6 sports for this. Next one, please. It will take like, it will kind of impact on the dynamic. Those are the objectives, the pillars of the PLOTO project. And in the next slide, you will see the combination of the consortium. Next one, please. So we put together the stakeholders and also the responsible parties that are involved in making the assessment of all the endowment that exists at the level of the port, and also supporting the exposure model and then follow up by the business operational model. And we are a combination of public-private partnership, meaning that one of the partners is a cluster, the Romania River Transport Cluster, which is an umbrella, an NGO in which both universities from Galați, also port operators, also port managing authority, not port operators, sorry, and other private actors are members. The other partner in the consortium is the administration responsible with everything that is related to inland waterway. It's AVDJ. And last, but being a part of our consortium, very active, is the Danube International University. Next one, please.
Sorry, Natalia. Gino, I think you shared the wrong screen. Can you make it a presenter? I think you should click on the 3 dots there.
I think Dimitrios actually invoked the Kraken. For sure, yeah.
What are you seeing? Sorry, because to me it was showing
so go to the presenter mode, yes.
Yes, and now if I go full screen.
Yeah, and then
it was showing the.
Yeah, exactly. I see also the next slide, which is good for me, but I think, yeah.
Okay, now you can see the full one. Is that correct now?
No, I see also the next slide.
Try that one. I think if you click on the 3 dots.
You know, I am on already in the presenter mode, and so okay. Share content, and now.
Yeah, but you should share it like the full screen.
Yeah, you know.
But it's
to me, it shows the full screen, so you're seeing.
Yeah.
For us, it's like the first and the second, but I can do this dance also. Don't worry.
Let me try again. Now? No.
No.
No, it's the same, but we can go with this. And also, I think we will share with all the participants all the presentations, so they will have the possibility to.
Sorry.
Have a life of its own. It's a life of its own, for sure.
Yes. There we go.
Oh, Erica. That was great. It was a very powerful consortium, guys. So we have a lot of energies coming together.
Sorry for the
No
sound.
worries. Thank you.
It's great. Okay.
Go ahead, Natalia.
Thank you for your support. Yeah. So as I was saying before, we are a combination of partners with different experience and expertise in the area of naval sector. And we put together also in order to design, and we had the goal to design a use case that has the most number of ports at the level of the all three use cases. Next one, please. And you can see here, like a glance, like a visit card of the ports that we selected in the geographical context, and also just a glance of them in order for you to be able to learn more if you need it or ask us to provide more information. So in alphabetical order, we choose the Brăila port. We built a complex of ports in Galați because both of them were very interested to us, so we are not able to choose between Port Docks and New Basin Port. Tulcea Port, Isaccea, and Sulina. The first two, Brăila and Galați Port Complex, are the one that have also the freight, and the last three are focusing on passengers. So in terms of seeing exactly how different events can impact the activity of the port, the economic value of the businesses that are taking place into the port, we choose also the one with the freight and the one with the passengers. Next one, please. You can see that in the platform, you saw it before, that there are different events identified in terms of drought, in terms of flood, in terms of even earthquake, if it is the case. For the Romanian use case, putting together all the data that you see here in terms of water level, hydrographical data, meteor data, GIS, river, ice coverage, if it's needed during the season, because the project was implemented on the duration of 4 years, we choose flood as being the one that has most impact in terms of use case implementation. Next one, please. Okay, just a quick view of the ports that we chose. So you see here the port of Brăila, you see the image of the port and also the location. The next one, please, because we will go a little bit faster on this. Next one. Galați with the two ports that I mentioned before. Next one, please. Isaccea also. Next one. We just have two more. It's Sulina and Tulcea. For you just to have the image, the picture of the ports with all the information in terms of location and activity that is happening. Next one, please. And you can see here that we did the analysis of in terms of event and the probability that this type of events would happen at the level of the port that we identified. And you see in red that flood was the winner actor, so to speak. So we focus on what would happen in the ports if different floods are going to occur. Next one, please. This is the type of data. As I spoke before, you saw the scheme. We collect at the level of the consortium, with the help of the stakeholders of the ports that we identified, different types of data in different period of time in order to be able to build a solid database that will become the entry data for the PLOTO platform. Next one, please. You see here the sensors that are put on the map. Next one. Yeah, next one. It's different types of sensors from which we collected the data that represents the information used within the PLOTO platform in order to have the results, in order to create the alarms for the beneficiary, in order to be able to design the mitigation measures. Next one, please. And it's different types of development of data during a different period of time. So here you can see the hydrological data. Next one, please. You see here hydrographic data. Next one. You can see also the location. This is also the data with the sensors. Next one. Meteorological information, because you saw at the beginning when the PLOTO platform was shown to you, you saw that you can actually pin also the meteor station that is providing the data. Next one, please. The same, it's meteor data with different parameters. Next one. Next one. And right now, because I told you that 3 ports were focusing on, that included also freight, so cargo in terms of business operation, we kind of had to do a mapping, an inventory of the port traffic evolution, the cargo that is being used, it is being used as a business in different areas. And we identify, you can see here, starting with scrap, with grains, fertilizer, stone, gravels, different types of cargo, and also different types of quantity. Next one, please. You can see here also the cargo, the dimension of the cargo of the freight in the specific unit of time. Next one, please. And right now, getting into business, the first one, it's Port of Brăila Romanel, which is private owned and private operator. And we provided the data related to the assets of the port. And with the help with our colleagues from the consortium, we kind of collect the data in real time using drones. I know that drones is like a very used term these days, but we kind of used drones in order to map up exactly what is on the ground and how it is the interaction. Next one, please. We put together also we did the mapping of the components of the port in order to design the business node. Next one, please. You can see here the data in terms of cargo, put it in different columns in terms of type of cargo, in terms of maritime or fluvial transport mode. Next one, please. And you saw this also at the level of the presentation of my colleagues, because we design the business operational model in order to be able to exactly say what is going to happen if an event like flood is in place or is forecasting to be in place. So the mitigation measures that can be transformed into financial values to be prepared in real time, and also the recovery after the event to be as shortened as possible. Next one, please. Those models are designed in terms of different types of cargo taking into consideration. So we got into details as much as possible in order to see exactly, after the setting of all the endowment of the port, to see also the flow of cargo and to see exactly how different parts of the business are going to be affected and how can this recuperation term to be a little bit more advanced, to be shortened. Next one, please. So you have here the bulk material. Next one. And we go to so we did this for every port. Galați was special, and was special in terms of also because it's a maritime and also fluvial node, and also because we put together the information from 2 ports together in order to see exactly how a more complex business model is in the operational mode, so to speak. Next one, please. You can see the information. You can see right now, like the mapping of the facilities and the assets of both ports. Next one, please. You see the information in terms of assets from the Google Maps for both the ports. Next one, please. And right now we are going to the juicy stuff in terms of having exactly to see the handling, meaning the what is the operational model for different types of cargo. And right now you can see it for bulk materials and products. Next one, please. You can see it also for stone, timber, iron, and other type of cargo. Next one, please. Handling of cereals. Next one, please. And handling of scrap. Thank you. Next one. So you saw a little bit of the dynamics of the cargo and the type of the cargo that is happening at the level of the complex and how it's going to affect the activity in the port. Right now we are going to a smaller port, that is Csiszár, that is a smaller port in terms of, okay, there is a passenger traffic there, but take into consideration the geopolitical environment, it will gain more and more support, structure, and different facilities. Next one, please. So you can see the images of the ports. Next one. You can also, next one, please, the terminal that is there, making the connection with the cross ferry from Ukraine. Next one, please. And right now, the operational flow chart, like it is in place with the passengers, and also it was a discussion taken into consideration because the operational of the port was increased starting the war in Ukraine. If it is the case for the port activities to be widened up in different areas, this is an open discussion, and we are very keen to see how it's going to be developed. Next one, please. You can see also the correlation with the other party from Ukraine. Next one. The port of Tulcea, which is a touristic port per se, and you are going to see a dynamic that is comparable to Csiszár, but has something that is specific. Next one, please. There are different images. Next one, please. Next one. Next one. And right now, the port operational flow. And if you have the time, when you will have the access to the presentation, I invite you to put those two together and to see the differences between them. Next one, please. Okay. Next one. Okay. A small port that is Sulina that benefited from additional information due to another project that our colleague from AFDG have in place. So we were able to put the data at the newest data in place in order to see how they affect the information within the platform. Next one, please. Okay. It is the same operational flow chart, and you can see exactly the dynamics that is happening in Sulina. Thank you. Next one. Different types of information for having focused also on the passenger traffic. Thank you. Next one. Border control. Next one. Thank you. And right now, we put here a snapshot of the dynamics of the PLOTO. It's like Professor Vamvatsikos says, we had a free hand on behalf of the designers of the PLOTO platform, and we are able to put the information in terms the worst scenarios ever, the best scenarios, and to see the dynamics. Next one, please. What we learned when we did that is first we are able to create, meaning that the platform is agile, is flexible. We are able to create the worst scenarios ever that have a very small percentage of being able to be implemented in real life. But we had some room to play, so to speak. In the same time, we understood the fact that putting all this data in a platform that is acting like an open source and can be disseminated at the level of all the stakeholders, meaning that we are talking about the port authority, or we are talking about the port operator, or we are talking about different other entities that are doing business in the port. It's something that is very refreshing in nowadays, and it's creating like a space for them not only to see the information in real time, but also to interact when they see this type of movement. Also, another thing that we learn, and I'm grateful and honored to have the opportunity to share with you today, although or in spite of all the technical difficulties and whatever is going to happen, it's that this type of common events that put together in terms of R&D dynamics, also the academic sector, the experts that are involved in the real activity in the ports, the common public, the general public, all those experts, if they have the opportunity to share their knowledge, their input on the theme like mitigation for extreme events in the areas that they are living, they are working, they have kids to school, that is something that brings together the community and also facilitates the sharing of experience and expertise, which is very, very good. And also we learned, but that was like a plus that we have due to the design of the cluster, because we have all the stakeholders from both public and private sector being our members. So for us, it's easier to reach, to go to them, and also to be on the receiving end of some data, is that on every other project, even if it is you funded or not, if you engage all the stakeholders, the end user, the beneficiary from the beginning, from the birth of the idea, like we did in our case, it's increasing the percentage of success. So the last one, please, next one. Just to send you with a positive note, we put together some testimonials from our members in terms of how the platform is working, how do you find the process. And we kind of encourage them to be as creative in terms of using all the data that they have at their disposal, to use it, to put it in the platform, and to document what is happening. And it was something very, very good for us, because the designer of the platform issued some credentials for us, and we were able to share it with our members and also the entire consortium that was involved hands-on on the use case of Romania. Share the information at the level of the stakeholders from all the 6 ports outside, and were open to receive the idea. I'm hoping that I made you a little bit curious to just try the platform, to see how it's working, and to share the information, and to give us your feedback, what we can improve, how we can be better. It will help a lot. Thank you very, very much.
Yes, thank you, Natalia, for this great presentation indeed. And it's high time to hear from Benjamin, our third use case on the Wallonie region. Thank you.
Good afternoon, everyone. I expect that you can hear me and you can see the slides also.
Yes.
So, okay, perfect. Thank you. So I'm going to say a few words about this use case C, which is located in the Walloon region in Belgium. And I will briefly introduce what has been done, what is available on this PLOTO platform, and also which is the practical value of that. So we are interested in an area which is located within the Meuse basin. The basin of River Meuse crosses several countries, including France, Belgium. Part of the basin is in Germany, then the Meuse is in the Netherlands. And we focus especially on a stretch which is located between the city of Liège and the Belgian-Dutch border. The main river is, of course, the Meuse, and those waterways that are operated and managed by SPWMI, which is also a full partner of the PLOTO project. The waterways are partly controlled by wheels, which are located just downstream of Liège from one of them. Another one is further downstream, and will concentrate especially on this artificial channel, which is called Albert Canal, and that connects Liège to the sea harbor of Antwerp. And this part is of interest related to the part of flood hazards within PLOTO, because there are several locations with dikes that are of different type, different structures, but it leads to a polder setting, therefore some more vulnerability in terms of flood risk. It's also a very densely urbanized area with a lot of artificial constructions in the floodplains, and there are numerous critical infrastructures also, including for transport, for health infrastructures, and other aspects also. So when it comes to including dike breaching in flood forecast, flood predictions, there are these three components that need to be represented. You have the channels, the dike breach itself, and the floodplains. And this leads to a kind of multi-scale problem, because you have very different characteristic length scales between the floodplains, for instance, and the dike processes themselves. And so within PLOTO, those three components, the channels, the dikes, and the floodplains, they've been represented in a different way, including for the computations, depending on the component of the PLOTO platform. And within the PLOTO platform, as was demonstrated earlier, we have a number of so-called what-if scenarios that were pre-computed, and we also have short-term forecasts which are available. And then for the what-if scenarios, we use kind of high-performance computing with a very detailed 2D high-dynamic model, which are GPU accelerated, are computed with our academic model WOLF. And this is coupled to lumped physically based representation of the dike breaching, and that's again linked to the multi-scale aspect of this problem. Then when it comes to the short-term forecast, we don't use this very detailed model, which is not feasible in terms of computational cost, but we have efficient, simpler models that were actually calibrated or derived from the knowledge gained from the detailed 2D model, and are also coupled with the morphodynamic component for the breach. And then here you see the coupling is very tight with shared memory, for instance, between Python script and the Fortran model. So let's go first a bit more into the details of those short-term forecasts. How does it work? At the core of those forecasts, which are made available on the PLOTO platform, you have this efficient 1D hydrodynamic model coupled with the dike breaching component. Then it requires boundary conditions, including upstream. So we extended actually the computational domain to go up to locations where there are measurement stations on the river. So in other words, we are most interested in the central part of this sketch, but just to be able to set relevant boundary conditions, the domain was extended quite a lot further downstream and further upstream. For the very operational pipeline on the PLOTO platform, that means for the short-term forecasts, we use some machine learning approach for the hydrological forecast, and this machine learning tool is fed by the current river discharge measurements at stations, as shown here, and also by weather observations over the past 24 hours and weather forecasts over the next 24 hours, and this is updated every 24 hours, fully operational on the platforms. That's an overview of the stations which are used. And then an outcome of this pipeline are the forecasted channel and bridge discharge over the next 24 hours, which can be coupled with floodplain topography to have those dynamic inundation maps that were already shown. And then again on the platform, yes, all this is totally operational on the platform. And again, on the platform, those inundation maps, they can be combined with data on exposure, on the building types and locations, and then they can be translated into estimates of, on one hand, monetary damage, and on the other hand, also the degree of structural damage to the buildings. That's for the short-term forecasts, which are displayed on the PLOTO platform. You have also those what-if scenarios, which are pre-computed based on a very detailed model, taking a number of options into consideration. So we have those types of flood maps that provide information on the inundation depth, but also on the time of arrival of the water. And so if we take a step back, it's very important to highlight that continuously the PLOTO developments that have been shared with stakeholders in the region. Especially we had a meeting that was organized by SPWMI, again, a partner of the project, in January this year. This meeting was focused on dike bridging, modeling and analysis, and we disseminated the outcomes of PLOTO. There were also other stakeholders present there, including the counterpart of SPW on the site of the Flemish region in Belgium, and other research and knowledge institutes. In terms of practical value of the outcomes of the PLOTO project, you have those flood maps, inundation maps, especially the maps indicated the time of arrival of the flooding, and they can be used in practice by some of the stakeholders like SPW, so they could be used for emergency planning, for crisis preparedness. And this is very timely because there have been some evolutions in the regulations in Belgium, especially in the Walloon region, regarding the safety of dams and dikes also to some extent. And so specific emergency plans need to be developed for structures like those dikes. And of course, the methods that I just introduced and which are behind the product available on the PLOTO platform, they're of course transferable to other sites, Belgium, but also elsewhere in Europe. Then other possible practical use of the outcomes of PLOTO and what is available on the platform are those weather forecasts that could be used, for instance, as additional members of ensemble forecasts, which are already used in the region. That's it from my side. Thank you very much, and I'm available to address any question.
Thank you, Benjamin, and thank all the participants, for all the presenters for the great inputs. Now I think it's time. We are running close to the end of the meeting, as it was envisaged in the beginning. We thought to close it at 1 o'clock, but it's such a good meeting, such good presentations. We have quite a strong audience, so we'll allow for some more time to have questions from the audience. But before doing that, I noted that Csiszár put forward some questions in his presentation, and he provided answers as well, that they are applicable for the other use cases too. So since you are there and you are on, I would like to ask one of the questions that Csiszár had in his presentation. I took note of what were the main gaps when you had the initial use case assumptions, and then when you try to implement and deploy, the reality is different. So can you identify some main gaps there? dear Benjamin. And the same question, of course, goes for Natalia, yeah?
Yes, you are talking about challenges that remain.
Yes.
So one aspect which is important in use case C is this interaction with the dikes and the breaching. For instance, the fragility curves for those dikes, they were not there was not a lot of time to explore them very much in detail. That's a point that could be improved. I think other challenges for future improvements of the platforms and the procedures is also to have maybe a more explicit, more transparent communication on the uncertainties. There are many uncertainties that accumulate from the weather forecast with the hydrological components and other components of the calculations. And it would be probably very valuable to make them more explicit in the way we display the results on the platform. But it's already a very valuable tool. It's readily available. It can also accommodate more what-if scenarios, for instance. That's a possibility. We have the procedures which are in place now. It's possible to prepare additional what-if scenarios and have them also showcased on the platform. Yes, these are some points that are on the top of my mind.
Okay, thank you very much, Benjamin, responding impromptu on this question. I would like to see and hear Natalie, please, as well. Natalia.
Yeah, for us, because you saw that we are ambitious, and for us was one of the challenges getting the data updated, meaning that to have access to all the data from different ports in terms also of assets, but also in terms of flows of cargo, which is not an easy way to the most easiest information indicator to get. But that was the challenge that actually became an opportunity because forced us to kind of increase our interaction with different other actors that maybe we are like knowing terms, but not in depth, not actually exploring how we can work together. And right now, the plus is that it's a street that goes two ways. So that was one challenge. And the other one was actually an opportunity because initially we have also the ports from Iron Gate, but we changed it within the project because of the opportunity of creating a synergy with other project that it was happening in Sulina ports. So this type of a framework created us the opportunity to get the information at the level of the port like Sulina, which is not normally included in different other endeavors also due to the proximity of Ukraine. So for us were a lot of challenges in terms of data, but a lot of opportunities getting to know a little bit more closely the stakeholders and having the possibility to include some smaller ports in this endeavor, which is big. Thank you.
Thank you, Natalia. Shall I ask also Csiszár, who originally posed the questions that I took note of? Perhaps he wants to add something.
Thank you for the opportunity, but I cannot say any more issues in this sense. Thank you.
I appreciate that. Just for fairness, I wanted to address you as well. Okay, one more then question to our two panelists. How easy was or is for these use cases to be adapted to other sectors or operational contexts beyond this project scope? Natalia?
I must confess that we already kind of move a little bit in that direction because we have more ports that can be adapted to this. And the challenge will be to get the data in real time and to see exactly how flexible is the platform in order to include this type of assets, because right now it's designed on the assets on the specific sector. But the dynamic of the platform is for certainly the opportunity to replicate these results, at least at the level of whatever Danube region has to offer. So it is something to just take and build another project on this and actually create a very good platform at the level of the entire Danube region. Thank you,
Natalia. Benjamin, would you like to respond to this as well?
Yes, with pleasure. I would say that for the part on the what if scenario, it's pretty straightforward to transfer to other cases, because what you need are basically the standard input data for flood modeling, inundation modeling, and that's becoming very much readily available at many places across Europe. Then for the short-term forecasting, I would say the main challenge is what was just highlighted by Natalia, is to adjust the tool so that it can indeed in real time retrieve those weather forecasts, and then have some component for the hydrological forecast also.
Thank you, Benjamin. Exactly on time. It's 1 o'clock. So now it's time for the audience to ask questions. Please put questions in the chat so our speakers would respond. If there are any questions, please put them in the chat. I do not see any. So, Audrey, it's up to you if you want to close this meeting, or I could ask one or two more questions, but yes.
There's a question from Dimitrios.
Yes, indeed. Where is this question now?
Dimitrios asked
if you were to do this again today, what would you change? Professor Vamvatsikos asks.
It's only for us as use case, or for us as in general as partners, consortium?
Of course, you are the starting point. Audrey as well could respond, or anybody else could step in, but I expect some response from you preferably. Yeah,
looking back, because it's like 4 years, and I think right now it just hit me that there were like 4 years. It didn't feel like this. It was like flooded information, and then we had to have mitigation measures, pretty much like in PLOTO. But I think what I would have done differently, I would have engaged with our stakeholders in an early stage. I will have done this, although maybe not all the data was needed, but I would have done that from the beginning. And I would have had this type of events like we have today more frequently. That was great for the opportunity to put together all the heads involved in this project, and maybe to just already right now know exactly how we can use some of the PLOTO results in different other endeavors. So this I should have done differently. I'm glad that it was our first Horizon funded project. So although we have extensive expertise in different other funding opportunities, this was our trial project. And I'm very grateful for all of you for all the support and all the lifting that you provide for us, and to be able to meet in this point today. Thank you.
Thank you, Natalia. You've been a very valuable partner. Benjamin, I see you are ready to respond as well.
Okay, thank you, Nikos. So maybe one point that I would emphasize would have been to go deeper into multi-hazard from the beginning. At least for use case C, we focused a lot on floods. And actually, as the project evolved, we also received, for instance, a very remarkable simulations conducted by FMI, the Finnish Meteorological Institute, on the effect of winds on the use case. There was some analysis on the consequences in terms of waves on the waterways, but again, it was a bit too short to really completely address it as multi-hazard, and that would be maybe the addition that I would dream of for the next time.
Thank you, Benjamin. Before giving the floor to Anna Maria, she has raised a hand. I would like to ask Audrey as well. What would she do in a different way? Perhaps even in the project context or as project coordinator? She has the first and the last word in this.
Well, for me, I think what would I have done differently? Maybe a little bit less worried at the beginning of the project. You know, because in the beginning of the project, we have like such a big impact. You know, we have such a big objective that we need to achieve and maintain. And to be honest, at the beginning, I was a bit worried, but a bit anxious about how the project is going to be. But you know, with the right partners, with the right people inside the project, it's always a blast. Of course, we have challenges here and there, but we managed to go through it. You know, so. I would say, yeah, something like this.
And maybe also add some more events like this as per Natalia's suggestion.
Yes, definitely. Yeah. We try to have as much event as possible, but you know, the time is always not on our side. So.
Okay, thank you, Audrey. Anna Maria, please. I see you've raised a hand.
I think she's muted.
Yes.
I don't think she has the opportunity maybe to put it into chat. The platform has a life of its own today.
Yes, indeed.
The Nix should now be able she should now be able to open the microphone.
Anna Maria, can you switch your microphone? We cannot hear you if you have any question. No? Okay. Anyone else has a question meanwhile? I think, Audrey, we are back to you.
Okay. Then if there's no more question, well, thank you so much, Nikos, for moderating the session. And of course, thank you, Natalia, Benjamin, and Csiszár for your presentation. Yeah, we're getting to the end of the event, but there's always logistical thing that I would like to bring up. So if I could just take a moment of your time to please fill in the survey feedback that I just posted in the chat. It will take you literally 2 minutes to fill up. It's very, very short. Yeah. Of course, we need to. There's no free lunch, they say. So we need to show our the funding, the grant operator that we managed to do this. And yeah, well. I think that's it from my side. If there's no other question, then I think we can close the webinar today. Once again, thank you very much for everyone. Thank you for Gino, Nikos, Professor Vamvatsikos, Aggelis, and all the other speakers, as well as everyone who have spent the last 2 hours with us. Thank you so much. This is, of course, this is the end of the project, but hopefully this is not the end of our collaboration. Thank you so much. And then, yeah, I think that's it from my side. I don't know, Professor, if you have anything to say.
Just say thank you, everybody. That's all. Thank you.
Okay. Thank you so much.
Thank you,
And
dear
have a
friends.
nice
Thank you.
weekend.
Bye-bye.
Thank you.
Bye-bye.
Thank you,
Thank
guys.
you.
Bye.
Bye-bye.
Bye.
Bye-bye.
Guys. Bye.